Any questions?
What is the acceleration line that we did last week do? The acceleration line that we did last week, what does that do?
Technically, I guess it was due yesterday, but tomorrow. That work for you? Okay. Other questions?
I have one about the lab yesterday.
Yep.
There's two different questions that ask for a set of complete calculations. What all do you want included in that set of complete calculations?
Let's see, this was the finding the
This was the friction.
coefficient of kinetic friction.
Yeah, it's like a force diagram and then the equations, and then you want one set of complete calculations.
Yeah, as in, so from the equations of motion, you should be able to, I think I did it on the board in the other room.
This is what you're looking for, like just figure out velocity.
So the equations of motion would be a step before this.
Right,
But,
yeah, so
but going through, that's what I'm looking for.
this is to figure out
Yeah.
all these. Okay, that's what I wanted to make sure.
Just, it's mainly because in the past, I get coefficients of kinetic friction and I'm going, I have no idea how this person got this number because it's so far off. And so that, I just need to be able to go, okay, he knows what he's doing, this was a careless error.
And when you plug in for friction in that equation, is it the coefficient of kinetic that you put in?
It's the coefficient of kinetic for B and C and static for A.
Okay.
But A acceleration is 0. It's the same equations of motion other than you'd have F sub S and the acceleration is 0 for part A and F sub K,
Okay.
whatever your acceleration is for B and C. Other questions? All right. We last left off with a car going around a ramp. So, a rear view. And we figured that if the V is 30 meters per second, the angle is, the ideal angle, 42.56 degrees, so that the car can take the curve without sliding up or down. So let's change something. We're either going to change the angle or change the speed. That's perfect. Those two go together. So if I increase the speed, it's going to want to slide up. If I decrease the speed, slide down. If I increase the angle, it's going to want to slide down. If I decrease the angle, it's going to want to slide up. Okay. And this is indeed a rear view. Overhead view. All right, so let's change something there. Let's change the angle. Let's make that 30, I'm only using a 30, so let's make it 35-degree angle. And I want to figure out what is the minimum coefficient of static friction so the car does not slide. Now, in order to find the coefficient, we need some, for static friction, we need to have some, it's going to be an extreme. All right, we start out just like we've started out so many problems. Force diagram. One down, 2 to go. Going. And one to go. Yep, going which way?
Acting down on the corner.
Let's see, we dropped the angle, so it wants to slide up, so yeah. Static friction, because we're trying to find that minimum static coefficient, or coefficient of static friction. Force diagram, done. Acceleration, what's the direction of acceleration? And coordinate system, coordinate axes. Well, one of them is going to be the direction of acceleration. So I'll just arbitrarily make that my hat, or my habit. And the other one? I wrote it down. See if I remember that when we get to the equations. All right, decomposition. What are we breaking up?
Normal force and friction.
Okay. We did the normal force the other day. So I have weight acting down. This is my angle theta. So I've got this angle theta right here. Actually, friction is going to be slightly easier to break up. So I'm going to go ahead and do that one first. So my friction is acting this way. And it's breaking it up into a horizontal and vertical components. Horizontal and vertical because that's my coordinate axes. Well, I got a right triangle here. My hypotenuse is friction. One of them is going to be the hypotenuse times the cosine of theta. One's going to be the hypotenuse times the sine of theta. Which is which?
Cosine is the,
Wait.
Horizontal.
the horizontal.
So F cosine of theta. And that would make this one F sine of theta. All right, so I've got, write this a little bit more space. So I've got weight, so I've got my friction force is going to the left, F cosine of theta, and down. So I have F sine of theta. My normal force, the old normal force is going up and to the right. So up and to the right. In terms of breaking it up, my trig functions switch. So this will be y cosine of theta, and this one will be y sine of theta. And again, as mentioned at the end of class last week, this works if they're perpendicular to each other. Friction and normal force are perpendicular to each other, as they will always be, because friction force is parallel to the surface and normal force is perpendicular, which is why it's called normal. All right, so let's see, decomposition, equations of motion. All right. Change this to something other than black. All right. How many equations of motion will we have?
2.
All right. Somebody give me one of them.
In the I hat friction, it'll be the normal force times the sine theta equals, or no, plus the friction cosine theta equals A.
Or we can be slightly more specific. What type of A?
Centripetal.
Yes. Is that what you said? Or did you say the other one?
I didn't say the other one, I just said that one wrong.
Okay. Oh, okay. All right, one equation right there. We got the forces on the left-hand side, mass times acceleration on the right-hand side. It is indeed centripetal because it's traveling in a circle. Or at least a curve at that point. Maintaining a constant speed. All right, one more equation of motion, because somebody told me there'd be 2 equations.
Would it be in the J hat direction?
Yep.
Y cosine theta plus zero?
There's two issues. Possibly one of them is my hearing, but
What's it? F sine theta minus y cosine theta plus b.
say it again.
F sine theta minus y.
Okay, those are just the corrections. All right, yeah. Down was chosen to be positive because that's just the way Luis rolls. I think I was giving you credit for that. So if someone else said down is negative, then, or down is positive, then you deserve the credit for that. So that's why the down ones are positive, and there are 3 forces vertically, so there should be 3 terms here. I was gonna stick F sine theta over here, that's why I put the gap. All right, and again, one of the reasons we choose coordinate system the way that we did is so that one of the equations ends up being equal to 0. All right, what comes after equations of motion?
Substitutions.
Yep. So for what do we have an independent equation? Oh, that's something else.
Weight,
All right, what's the formula for weight?
mass times G.
Okay. So I got a separate formula for weight.
And acceleration.
And what's the formula for acceleration?
V squared over R.
Right? Or
Omega squared L times L.
big square R.
V squared.
It just, the L came out specifically for that one problem.
Okay.
So it's omega squared times whatever the radius of the curvature is. However, V squared over R is the one that we want in this particular case. And we have one more equation, independent equation.
Friction.
Yes. And what's the formula for static friction at the extreme?
So that's.
Yes. So this one becomes y sine theta minus u sub s y cosine theta is equal to m v squared over r. And the other one becomes, I'm just gonna go ahead and I'm gonna bring weight over to the right-hand side. Actually, I want weight isolated, just because I know where I'm heading on this one. So I got y cosine theta minus f sine theta is equal to mg. Oop. U sub s, y. Wow. Let's see if I can do it slightly here. Right. So in essence, I added y cosine theta and subtracted f sine theta over to the right-hand side and then just flip the sides. All right, I now have, I know what theta is, I don't know what m is, but that's gonna go away. I know v, I'm gonna stick with 30 meters per second. I know r, which I didn't write over here, but it was in the problem the other day. The radius of curvature is 100 meters. Assume it takes place on Earth, so I know g. So my unknown is y and u.
Why is the, why are we subtracting mu sub s y cosine theta in the first equation?
In this one,
Yeah.
because I made a mistake.
Okay.
Thank you.
You're welcome.
Hey, it happens. Any others? Any other questions, comments, concerns? All right. So how do we solve it? I'm solving from u sub s. All right, what do I want to get rid of?
M,
Mass.
mass,
Wait, sorry?
M,
Oh, okay, I do want to get rid of m. I want to get rid of something else also.
Y.
Yes. My unknowns are mass, y, and mu sub s. I'm solving for mu sub s, so that's gotta stay. Y I need to get rid of, m I need to get rid of. So now it's just a matter of how do I do that? And there are several techniques that you can do. If you solve for y, and then plug into the other equation, that would work. You'd end up with a mass on both sides that were factors, and you can cancel them out. I'm gonna do a similar thing to what I did yesterday. I'm just gonna factor y out to start with. So I have y times sine of theta minus us cosine theta equals mv squared over r. I'm gonna do the same for the bottom equation, factor y out on the left-hand side, and I'm left with cosine of theta minus, that should be a plus up top, man, depends if I can do that. Us sine theta is equal to mg. I got my y's lined up, got my m's lined up, I'm just going to divide. I'll divide the left-hand sides and divide the right-hand sides. Y's cancel, m's cancel. So I'm left with, all right, this is the point in which I realize the more I write, the more chances I am to make the careless error. So I'm gonna make two small substitutions here, just as a shorthand. I'm gonna let s equal sine of theta. I'm gonna let c equal the cosine of theta. And so this reduces down to s plus mu c divided by c minus mu s is equal to v squared over gr. Now, if mu is 0, if we're dealing with frictionless situation here, those terms would drop out and we're left with a sine over cosine, which is tangent, which is what we had yesterday. Again, I know v, I know g, I know r, I can find cosine, sine, and so forth. I'm still solving for mu. Now the question is, how do I solve for mu? There are many ways. Wonder which is trial and error, which is a horrible way of doing it. Flashback to Algebra 1. All right, any questions on this? I'm about to rewrite that last equation on a fresh board here. Any questions on this before I go to a new board?
So S plus C minus.
S plus mu C over C minus mu S is equal to V squared over GR. Okay. Hey, math class, if you ever wondered, when are we ever gonna have to use this? Now's the time. Two fractions equal to each other, what can you do? Somebody said it. Yeah, let's cross multiply. So I have GR times S plus mu C is equal to V squared times C minus US. Now what can we do? Yep, all right. So I have GRS plus GR mu C is equal to V squared C minus V squared mu S. And remember, sine is, S is sine of theta and C is cosine of theta. We actually could get a real number for it, but why yet? Solving for mu, so now what?
Get used by itself.
Yeah, all right. So first we have to get the mu terms together, so I'm gonna bring this over to the left-hand side and that over to the right-hand side. So I'm left with GR mu C plus V squared mu S is equal to V squared C minus GRS. Trying to get mu by itself, as Kevin said, so we're gonna factor that out, so I get mu